Today and tomorrow we're going to be working on solving trig equations. We've already done these in the past. Those should be kind of a nice review for us. So let's go and take a look at the very first one. We have our equal sign. We kind of want to treat trig functions like variables. So we're going to bring over the sine of x. And that gives me 2 sine of x minus the square root of 2 equals 0. Now, I have to solve for the sine of x. So to do that, I'm going to bring over the square root of 2 and divide by 2. So I get the sine of x equals the square root of 2 all over 2. And what angle for sine gives us square root of 2 over 2? Remember, we call this our reference angle. And that, of course, is pi over 4, or a 45-degree angle. We will get two answers here. Because sine is positive, we're going to get two answers. Sine is positive in two quadrants. If you need to remember this, all students take calculus. So sine is positive in the first quadrant and in the second quadrant. So to get the first quadrant, very easy. That's just our reference angle, pi over 4. Quadrant 2, there's a couple ways you can do it. One, you can remember it. But if you don't, that's okay. Just do this. Here's my angle. There's theta. Remember, this right here, this angle right down here is my reference angle. So if I need to get my theta, it's just going to be my pi minus pi over 4, which is 3 pi over 4. Now, you don't have to use this method to get it every time, but it helps, if you need to. All right. You could just remember it also. All right. Number 2. We have 4 sine squared minus 3 equals 0. So solving it, just like anything else, we're going to isolate the sine. So I'm going to add 3 and divide by 4. So I get the sine squared of x equals 3/4. Now we have to undo the square, which means we have to take the square root. So we get the sine of x equals, we get two answers here because we take the square root. We get the positive or the negative, the square root of 3 over 2. The square root of 3 we can't, but square root of 4 is just 2, so we can just rewrite it. So I'm going to write this down, and I'm going to separate this into two equations now. I get the sine of x equals the positive root 3 over 2, and the sine of x equals the negative square root of 3 over 2. Get your reference angle. They both will have the same reference angle, because just reference angle we don't want the positive anyways. And where is sine equal to root 3 over 2? Pi over 3. So for the first one, for the positive, sine is positive in the first and second quadrant. So again, we're going to get pi over 3. In the second quadrant, we're at 2 pi over 3. Where is sine negative? Sine is negative in the third and fourth quadrant. So we get theta in the third quadrant, it's going to be 4 pi over 3, and in the fifth quadrant, 5 pi over 3. So we actually get 4 answers in this case. All right. Questions? Try them again if you need to, and we'll see them in class tomorrow. All right. Let's take a look at the next one here. Now this is kind of a tricky one. What students tend to want to do, they want to divide out a sine of x. Unfortunately, you can't do that. So we actually have to do a little bit of an algebra trick here. We must equal 0. Write that down. Must equal 0. You cannot solve a quadratic by canceling. You have to factor. So we get the sine squared of x minus 2 sine of x equal to 0. Now, what do they both have in common? Sin. That's right. Just teasing. Anyway, they both have sine in common. So I can factor out a sine of x. And that's going to give me sine of x minus 2 equal to 0. We're going to use the zero product property. And what that means is we take each one of those, set them equal to 0. Sine of x equals 0. And over here, this becomes sine of x equals 2. Now, we know where sine is 0. Now, if you need to, just use your quadrantals. 0, 1, 1, other way around. 1, 0, 0, 1. Negative 1, 0, 0, negative 1. Sine is my y value. It's 0 at 0, and pi, and 2 pi. Now, unfortunately, remember, our domain only goes to 2 pi, so we don't include it, it's open, so we only get 0 and pi. Now, where does sine equal 2? Now, that's a tricky one. There is none. Remember, that's outside the domain. So we don't include that one. Nice. We like it when that happens. All right, so let's take a look at number 4. Now, number 4 is an oldie but a goodie. We like number 4 down here. So if we can take a look at that one together. We have 2 sine squared of x minus 3x plus 1. We're going to have to factor, okay? It's not too bad. If you need to, rewrite this as 2x squared minus 3x plus 1. Sometimes it's easier to factor using x's and not using the signs. This becomes 2x, a 1, x and a 1, both negative, equal to 0. So when I solve it, this becomes x equals 1/2. Here we get x equals 1. Now the only difference is, remember, we are using sine. So now I have to replace this. This is really the sine of x equals 1/2. The sine of x equals 1. And we get our 2 answers from here. All right. So, to get our first one, get your reference angle. Well, where is sine equal to 1/2? Pi over 6. It's positive, and remember, sine is positive in the first and second quadrant. So in the first quadrant, we know it's pi over 6. In the second quadrant, that's 5 pi over 6. And remember, you can always use the same method we did for number 1 up here by subtracting if you can't remember what they are. The next one, where is sine equal to 1? Well, that should be pretty easy. Where is sine equal to 1? This one we should just know. It's pi over 2. You want to know that one. All right. Let's take a look at number 5 here before we move on to part 2. All right. Now, number 5 is a little different. It looks similar to number 4 that we're going to have to factor, but you got to be careful. Different terms. So we have to convert. We either have to convert secant squared to tangent squared or tangent squared to secant squared. And hopefully you remember the little rule here for our Pythagorean. That's this one, that we know 1 plus the tangent squared of theta of x equals the secant squared of x. That's one of our identities. I'm going to use that to replace my secant squared. So now what we get is 3 times 1 plus the tangent squared of x minus 2 times the tangent squared of x minus 4 equal to 0. I replace it, substitution. You want to keep them in terms in the same trig identity, or trig function. Distributing, 3 plus 3 tangent squared of x minus 2 tangent squared of x minus 4 equals 0. Solving it, combine the like terms, I get the tangent squared of x. Oh, look at this, combining here, minus 1 equals 0. Solving it, the tangent squared of x equals 1. Take the square root. Remember, we get 2 answers. We get the tangent of x equals 1, or the tangent of x equals negative 1. Now, for tangent to equal 1, this is where sine and cosine equal. This is where sine of x equals cosine of x. So my reference angle, very easy, is pi over 4. And where is tangent positive? It's positive in the first and third quadrant. Remember, all students take calculus. That's where tangent's positive. So the first quadrant, got that. In the third quadrant, remember, this is going to be 5 pi over 4. Or if you need to, just take pi plus the pi over 4, and that'll give you the same answer. Where is tangent equal to negative 1? Same idea. The reference angle is still pi over 4. But now we're talking about negative. Where is tangent negative? Second and fourth quadrant. So in the second quadrant, that's 3 pi over 4. And in the fourth quadrant, that's 7 pi over 4. And there's our answers. All right, take a look at these, try these again if you need to, and then go on to part 2. Thank you.